Hey you guys, this is Unit 2 Notes number 4. So we're actually approaching our fourth lesson on solving rational equations. As you've noticed, it gets progressively more critical in terms of the moves that you guys make, but not necessarily more difficult, okay? Same FLT. So press play whenever you're ready, okay? Okay, so here we go. Here's example 1. Go ahead and write it down. Pause if you need to. Press play when you're ready, okay? So we're going to approach this problem the exact same way, okay? If you guys can remember, what is the absolute first step that we have to make? Okay? Hopefully you're thinking domain. Don't get to any solving until you've taken care of the domain here. So domain, we look at the denominators. So we have to make sure that our denominators, x plus 7, x minus 7, and x minus 7 doesn't come out to 0. But again, you don't need to write it twice as we did right here. And some of you are figuring out that you could kind of just see what x can't be, and if you're ready for that, you could do that too. X plus 7 can't be 0, and x minus 7 can't be 0. We're not going to write it twice. So here, x cannot be negative 7, and x cannot be positive 7. So we're going to keep that there. We'll look back later when we have to check our answers, okay? Okay. So here we go. Let's go ahead and bring this down here so that it's not too cluttered. Okay, here we go. First thing you want to do is you want to make sure that you get rid of your fractions, okay? Because that'll make things significantly easier. So if I want to get rid of this x plus 7, I'm going to multiply x plus 7, but I have to do it everywhere. Okay. I noticed that that'll get rid of my x plus 7s right here on the left, but nowhere else because this is an x minus 7. So to get rid of that, I have to multiply by x minus 7. This is called our least common multiple. If I do that there, I'm going to have to multiply by x minus 7 everywhere else. Okay, so let's go ahead and see what reduces out here, okay? In the middle, x minus 7 will reduce out because we have one at the top and the bottom here. Same thing over here. To help you guys out, I'm going to go ahead and highlight what we have left. We have a 3 left times the x minus 7 plus 7, and that equals 7 times x plus 7. Okay? You got to be really organized and neat with your penmanship, okay? Otherwise, things are going to get a little bit cluttered. So I'll write this out. We have 3 times x minus 7 plus x times x plus 7 equals 7 times x plus 7. Okay, now that we don't have fractions anymore, it's a little bit more easier to take care of, okay? So I noticed that there are a lot of parentheses. I'm going to go ahead and distribute like crazy, okay? So 3 times x is 3x. 3 times 7 is negative 21 plus x times x is x squared. X times 7 is 7x equals 7 times x is 7x. 7 times 7 is 49. So a lot of distribution here, but nothing that you guys cannot handle. Okay, so notice how I have a quadratic, so I want to make sure that one side is 0. But before I do that, maybe I could clean things up a little bit on the left-hand side here. I noticed that 3x plus 7x gives me 10x. And the x squared I'll just put in the front because that's how we normally write it. And the minus 21 I'll put over here. Okay. All right, so since we have a quadratic, we're going to try to solve this using the zero product properties. First thing is we have to get a 0. So we're going to try to move these two things over here. The way we do that is we do the opposite. So if I subtract 7x here, I should subtract 7x right here. And if I want to move my 49, I'm going to subtract 49. And it only makes sense to combine it with the 21 that I have right here. All right. Right-hand side will come out to 0, which is what we want. Now I have x squared plus 10 minus 7, that's a positive 3x. And negative 21, negative 49, since they're the same signs, we're going to add. We should get negative 70. Okay. So I have my 0. Now I need a product, okay? So in order to get a product, I need to factor it. So here we go. X times x will give me x squared, so that's pretty easy. I'll put that in there right away. Now here, 70, you could use a lot of combinations. For instance, I'll write it on the side here because we don't have room. We could do 1 times 70. We could do 2 times 35. We could do 10 times 7. Okay, there are a lot of combinations here, but remember, we're trying to get positive 3x. So what numbers do you think will get you that, okay? Okay, so I'm going to go ahead and use 10 and 7. Okay? Now, notice how the constant is negative, so that means you'll have different signs, okay? If your constant is positive, you're going to have the same signs. So plus, plus, or minus, minus. But if you have a negative constant, you're going to have different signs here. So I'm going to go ahead and make the 10 positive and the 7 negative, okay? And if you're not sure, you could always guess and check like I am going to do right now. My outer x times negative 7 is negative 7x. Positive 10 times x is positive 10x. That gives me a positive 3x, which is exactly what I want, okay? Okay, so now that I have my 0 product, I'm going to use the 0 product property, which allows me to set each factor equal to 0. Okay, so if you solve this here, eventually you'll get x equals negative 10 and x equals positive 7. But before I box it, do I have a conflict with my domain? Let's go back. At the beginning, I said x can't be negative 7 or 7. So let's take a look. There's a conflict here. So we call that extraneous. Hopefully you guys are seeing the patterns from the last set. So we actually only have one good solution. Okay, hopefully that was all right. There's a little bit more algebra in between, but nothing that you guys cannot handle. All right, feel free to replay that if you need to. Let's move on to part B. Okay, now I encourage you to try this one out on your own. Okay, and if you are done or if you happen to get stuck, you could always press play. Okay, so pause right now and then go ahead and try this on your own and press play whenever you're ready. Okay, so hopefully you had time to start a few of the steps, if not all, but hopefully the first thing you did was you checked the domain. A lot of people tend to want to jump into the solving right away, but be careful with that, okay? So here you should have gotten that x can't be 9 or 4. All right, this one here is a little bit easier to see, so I'm going to write it like that. And if you're not comfortable with that, write everything out, okay? Okay, so here we go. We have our rational equation. First step, to get rid of all of your denominators. So I want to multiply by x minus 9 everywhere. But I also want to multiply by x minus 4 everywhere. This is called our least common multiple, okay? So let's see what cancels out here. Whatever you have at the top and the bottom, you can reduce out. So that reduces out. X minus 4s will reduce out here, and x minus, whoa, and x minus 4s will reduce out here. I have the quantity of 2x plus 3 times x minus 4 plus x times x minus 9 equals 2x times x minus 9. Okay? Still a lot, but a lot easier to deal with. So here we go. We have 2x plus 3 times x minus 4 plus x times x minus 9 equals 2x times x minus 9. Okay, over here, in the middle, x times x is x squared. X times 9 is negative 9x. Over here, 2x times x is 2x squared. And 2x times negative 9 is negative 18x, okay? Now, right over here, you have two binomials, 2 terms times 2 terms. So you're actually going to have to FOIL or use the box or distribute, whatever you guys are comfortable with. I personally like to just distribute and draw arrows. 2x times x is 2x squared. 2x times negative 4 is negative 8x, okay? Then 3 times x is positive 3x, and 3 times negative 4 is negative 12. I should put a plus here for the x squared. Okay, so a lot of distribution, but just stay organized, okay? Here we go. I noticed that 2x squared and 1x squared becomes 3x squared, and negative 8x plus 3x minus 9x can all combine. Negative 8x plus 3x is negative 5x. Negative 5x minus 9x is negative 14x. Make sure you guys understood that before you move on, okay? And then I have this minus 12 here. All right? Equals, the right-hand side is just 2x squared minus 18x. Okay? So, same idea. Since we have a quadratic, we're going to try to use the zero product property. Okay? So first we got to get a 0. So let's move these two guys over here. And the way we do that is we do the opposite. So minus 2x squared. So x squares go with x squares. And negative 18x, I'll add 18x. And it makes sense to add 18x right here with the 14, okay? That'll give me a 0. Good. 3 minus 2 gives you 1x squared. Negative 14x plus 18x, different signs we subtract. Keep the sign of the larger number. You should get positive 4x minus 12. Okay, so we have our 0. Now we need our product. Okay, so it should be x and x. And here you could either use 1 and 12. You could use 6 and 2. You could use 4 and 3. But 6 and 2 would probably work because you're trying to get 4. Now remember, the constant is negative, so you're going to have different signs, okay? So I'm going to put the plus here and the minus here. Let me go ahead and add another page here so we have more space. Okay, so here, since I have a product equal to 0, I can split. I can set each factor equal to 0. Now, I didn't go over the checking, but you guys should definitely check, okay? Check your outer and your inner. Okay, so eventually you should get x equals 2 and x equals negative 6. All right, but before I box this, let's go back and check our restrictions. At the beginning, I said that x cannot be 9 or 4. Do we have 9 or 4 here? We don't, so we have 2 good solutions. So on delta math, you would just write x equals 2, comma, then negative 6. Okay. So again, it's the same steps, but a little bit more algebra. And personally, this is where you get really good with your algebra. Okay, because you have to pay close attention. So take your time here. Here's part C. Okay, so first step, as always, domain. Okay, so here's what you guys can do to speed things up, okay? We know that our three denominators cannot be 0. Okay, but there's something fishy about this right here. Anytime you have a square in the denominator, you want to see if you could factor it out, okay? So what you can do here is you could factor that. Pause here and think about what the factors are, okay? And press play when you're ready. You should have gotten x and x, and you should have used 6 and 4. Since 24 is positive, you're going to have the same sign, so either plus plus or minus minus. In this case, you want to do minus minus because that'll give you negative 6x. This will give you negative 4x, and that'll give you negative 10x, which is exactly what you want. Plus plus wouldn't give you that negative in the middle, okay? Okay, so here's what you do. You go ahead and you're going to replace that highlight for the factored form. So this will be x minus 4, x minus 6. If you notice, that makes your domain a lot easier. If you just take a look at all of your denominators, you could tell that x can't be 4 or 6. Okay? So we'll keep that in the back of our minds. I want you to go ahead and try this one out and then press play when you're ready. So go ahead and pause here. Give yourself as much time as you need to. And then when you're ready, press play. Okay, here we go. So we're going to multiply by the least common multiple. So we're going to multiply by x minus 4 and the x minus 6 everywhere. That's the only way we're going to get rid of all of our denominators, okay? Because if we could get rid of our fractions, we can make things a lot easier to deal with. X minus 4s will cancel out here. X minus 6s will cancel out here. And both x minus 4 and x minus 6 will cancel out here. I'm going to have a 5 times x minus 6 plus x minus 4 equals 2x, okay? So I have 5 times x minus 6 plus x times x minus 4 equals 2x. A lot cleaner than what I had before, right? So now I'm going to go ahead and distribute because I see a lot of parentheses. I should get 5x minus 30 plus x squared minus 4x equals 2x. Now, if I'm going too fast, feel free to just replay it, okay? I noticed that negative 4x and positive 5x will give me a positive 1x. And then minus 30 I'll put here, and the positive x squared I'll put there. Okay? Since it's a quadratic, I'm going to try to get a zero product property going. So I'll go ahead and I'll subtract the 2x here, the opposite. And it only makes sense to subtract 2x right there in the middle because it's linear. So now that I have my 0, I have x squared minus 1x minus 30. Now that I have my 0, I need a product. The only way to get a product is if I factor here. And if you factor this correctly, it should be minus 6 plus 5. Okay? And again, you're only going to get better and faster at it the more you factor. So take your time, go at your own pace, and it'll eventually speed up on its own there, all right? Okay, so using the zero product property, that allows me to set each factor equal to 0. And then eventually you'll be able to figure out that x is negative 5 and x equals 6. But before I box it, let's go back to our domain. X can't be 4 or 6. Do we have that down here? Ah, we have it right here, so that is extraneous. It's an extra answer that doesn't work, so we only have one good solution there. All right. Okay. Part D. Okay, try this one out. Press play whenever you're ready. Okay, first step, domain. Okay, I noticed right away that there's a quadratic here, so I might want to factor it first. That'll actually come out to x plus 3 and x plus 8. Okay. Hopefully you guys did that too. Okay, so that tells me that x cannot be -3 or -8. And if you're unsure how I got that, feel free to text me or to go back in the previous examples, okay? Okay, so here we go. All right, here we go. Let's go ahead and get rid of our fractions. So x plus 3, x plus 8. So I'm going to multiply that everywhere. Okay, so x plus 8 will cancel out in the middle here. Both x plus 3 and x plus 8 will reduce out. I have 1 times x plus 3 times x plus 8 plus a 1 times x plus 3 equals a 7. You really don't have to highlight. That's up to you if you have trouble seeing what you have left, okay? So we have 1 times x plus 3 times x plus 8 plus 1 times x plus 3 equals 7, okay? Over on the left here, if you multiply something by 1, it really doesn't change anything. Same thing here. So right here, I'm just going to have x plus 3. And over here, you know, that was a factored version of what I had at the very beginning. And if you guys remember, it was x squared plus 11x plus 24. If you didn't remember that, you could just FOIL it out or distribute like you always do. You'll eventually get x squared plus 11x plus 24. All right? Okay, equals 7. I noticed that 11x and 1x makes 12x. And 24 and 3, same signs we add, we get 27. And then we bring everything else down. Now that I have a quadratic, I want to use the zero product property. So first step is to get a 0. So I subtract 7. That'll give me x squared plus 12x plus 20. Different signs we subtract, we keep the sign of the larger number, okay? And now that I have my 0, I need a product. So here we go. The only thing that seems to work here would be x and x. And if I want to get 12, I might want to use 10 times 2. And since everything is positive, I'll just put plus and plus. Okay. So using the zero product property, that lets me set each factor equal to 0, which tells me that x is -2 or -10. But before I box it, let's go back. The domain is x can't be -3, -8. Doesn't look like I have any conflicts here, so I have 2 perfectly good solutions, okay? So on delta math, you would just write -2 and then -10. Or the other way around, it doesn't matter, okay? Okay, here's the last set, all right? Part E, write it down, and then press play when you're ready. This one is not that different, except you have to kind of revisit what you've learned way back in the day, okay? So first step, as always, is the domain. But I noticed that there is a quadratic in the denominator here, okay? If you guys remember, there's a very unique way of factoring that. Feel free to look back if you guys need to. But that right there is a difference of 2 squares. That, I'll sidebar this for you, is the same thing as x squared minus 3 squared. And when you have a difference of 2 squares, you can factor it as x and 3, x and 3 with different signs. That was called difference of 2 squares. We called it dots way back when, okay? So what I'm going to do here is I'm going to go ahead and erase x squared minus 9. You could cross it out if you want, but I'm going to replace it with x plus 3 and x minus 3. When our denominators are factored, it makes things a little bit easier, okay? So if you're taking a look at all of your denominators here, x cannot be -3 or +3. All right? Okay, so go ahead and pause now and solve this one here. That should be enough for you guys to take care of. Press play when you're ready. Okay, so first step, multiply by the LCM, least common multiple. Okay, I noticed that x plus 3's will cancel out here, x minus 3's will cancel out here, and both will cancel out on the right-hand side. I have x plus 5 times the x minus 3 plus 2 times x plus 3 equals that 3. Okay, so here we go. We have x plus 5 times the x minus 3 plus the 2 times the x plus 3 equals 3. A lot of distribution involved. You're going to have to distribute a lot over here. So that's x squared. That's -3x. That's +5x. And that's -15. Over here, it's 2x plus 6 equals 3. Okay, so -3x plus 5x plus 2x gives you, I think, a total of 4x, okay, positive. And -15 and +6, different signs we subtract, keep the sign of the larger number, that'll be -9. I'll bring down my x squared and my equals 3. Now that I have a quadratic, I want to make sure that I use the zero product property. So first step is to get a 0. Hopefully you're tired of me repeating the same steps. That means that you understand the process, okay? So right-hand side will be 0. We have x squared plus 4x. Same signs we add, then we keep the sign of the larger number. Okay, now that I have my 0, I want my product, right? So hopefully you have enough time to do that. If you want to pause here, you can. And press play when you're ready. This should come out to x plus 6 and x minus 2. Or the other way around, x minus 2 and then x plus 6. Okay, that allows you to use the zero product property. So here x is -6 and then x is +2. But before I box it, I look at my domain. X can't be -3 or +3. There are no conflicts here, so I have two good solutions. So you would just write x equals -6 and +2. No need for the positive, okay? Here's one for you guys to try, but I'm going to end it here. Yeah, text me if you guys have questions, okay? Take your time. You're going to be just fine.